So in this problem, we need to find a vector valued function r such that it satisfies this given differential equation. There's a second order differential equation, and it's given that at t equals to 0, t is a scalar parameter, and when it's equals to 0, r vector will be 2i cap plus j cap, and first derivative of r with respect to t, so that will be negative I cap minus 3j cap. So let's begin. So let's rewrite the equation. So we have second derivative of vector r with respect to t. So this will be equals to, so we are given 6t I cap. So 6t is the x component minus 24t squared. So 24t squared, this is the y component multiplied to j cap, plus the z component is 4 sine t k cap. So let's call it equation number 1. What we'll do, we'll integrate both sides of equation number 1 with respect to t. This will be equals to 6 times integration of t dt. So that will be 1 over 2 times t squared I cap minus, we have 24 times integration of t squared will be 1 over 3 times t cubed j cap plus 4 times integration of sine t. So that will be negative cosine t k cap. So this is our derivative of r with respect to t. So let's simplify this. So this will become 3t squared I cap minus 8t cube j cap plus that's negative 4 cosine of t k cap. Now whenever we are integrating, we have to make sure that we also include the constant of integration. So let's call the constant of integration as c1. Now here c1 is going to be a constant vector. It's a vector, that's because on the left hand side we have a vector which is dr vector over dt, and on the right hand side each of the terms are vectors. So here we have I cap, j cap and k cap. So that means the constant that we're adding to it must be also a vector. So that means c1 is a vector. So it's simply a constant vector. We'll have plus c1 vector. So let's label this as equation number 2. Now what we will do, we will integrate both sides of equation number 2. So that's going to give us vector r equals to 3 times integration of t squared dt. So we're integrating with respect to t times I cap minus 8 times integration of t cubed dt multiplied to j cap minus 4 times integration of cosine of t dt multiplied to k cap plus c1 vector multiplied to integration of dt. So let's simplify this. So we will get 3, so integration of t squared will be 3 over 3 t cubed I cap minus 8 over 4 t raised to the power of 4 j cap minus 4 times integration of cosine function will be the sine function k cap plus c1 vector multiplied to integration of dt will be t. Now we will have another constant of integration, so let's call it c2. Similarly, c2 is also going to be a vector. So we have the constant vector c2. So this is number, we'll label this as number 3 in the next step. We'll further simplify it. So this gives us r vector, so that's equals to t cubed I cap minus 2t raised to the power of 4 j cap minus 4 sine t k cap plus c1 vector t plus c2 vector. So here this is what we are asked. So we have to obtain this r vector. For that we'll have to obtain the value of c1 vector and c2 vector. We are already given the condition. There are a few conditions that are given to us. What's the nature of the vector r and its first derivative at t equals to 0. So let's use them. So let's start with equation number 2. So here we have the first derivative of vector r with respect to t calculated at t equals to 0. So that's given as, that's equals to negative I cap minus 3j cap. So this will be equals to, so we'll come back to our vector. So here 3t squared, so that means we have 0 I cap minus 8t cubed, so that will be 0 j cap minus 4 times cosine of 0 is 1. So we have negative 4 k cap plus c1 vector. Solving for c1 vector, so we have c1 vector as given by negative I cap minus 3j cap plus 4k cap. So let's label this as number 4. Right. And we have provided with the fact that r vector calculated at t equals to 0. So that's equals to 2I cap plus j cap. So this will be equals to, so we'll consider equation number 3. So here we have t cubed I cap, so that will be 0 I cap minus 0 j cap minus 4 times sine 0, so that's 0. All of them are 0. We have c1 vector times 0, so that's also 0. So we have only c2 vector. That means c2 vector is equals to 2I cap plus j cap. So we have obtained, so let's label this as number 5, c1 vector and c2 vector. And what we'll do, we'll finally substitute this value into equation number 3. So let's do that. Vector r, that's given by t cubed I cap minus 2 t raised to the power of 4 j cap minus 4 sine t k cap plus c1 vector times t. So that means we have, we'll multiply this by t. So we have negative t I cap minus 3t j cap plus 4t k cap. And this is added to c2, which is simply 2I cap plus j cap. So we'll combine all the like terms together. So this will be, so we'll combine the components of I cap. So that means we have t cubed, then we have negative t plus 2. So these are going to be the components of I cap, plus we'll consider the j cap, components of j cap. So this will be negative 2 times t raised to the power of 4, and then we have negative 3t, and we have positive 1 j cap. This is done. And finally we'll combine the components of k cap. So that will be plus 4t minus 4 sine t multiplied to k cap. So this is going to be the value of the vector valued function r, which is going to satisfy our differential equation given by this particular differential equation, which is the second derivative of r with respect to t is equals to 60I cap minus 24t square j cap plus 4 sine t k cap, provided this condition holds when t equals to 0.